Hello, hello. Hi, Benji.
Hey Hugh, how's it going?
Good. How is your short week in theory going?
Yeah, not too bad.
Yeah, good. Did you actually get most of Monday off, step away from things, or not so much?
I did, yeah. Yeah, it was
Nice.
nice to take a break.
Yeah, that's great. Nice weather is rolling in where you are, or not so much?
Yeah,
Yeah,
it's a little bit overcast today, but it's been really pleasant.
yeah, that's awesome. Yeah, the nice weather makes it harder and harder to work. That's for sure. Oh, well, yes. So
How's
life
things
outside
with
of work
you?
is good though. Things are good. Yeah, yeah. Hectic. Yeah, my eldest daughter is she just finished her first year of university, and now she is moving into her first apartment by herself. So yeah, very interesting times around here.
Yeah, for
So
sure.
time flies without a doubt. We have a huge spread in kids though, because I have a 7-year-old and a 9-year-old as well. So quite a
Right.
spread.
Keeps it interesting.
Yeah, it keeps it interesting. That's right. It was nice. The older sister was the babysitter for quite some time, but now that she's out, it's like, oh, we don't have an in-house babysitter anymore. That
Oh
sucks.
no.
Exactly. Now, don't get me wrong. She was pretty quick with her invoice. It's just the way it is. Hi, Rob. How are you
Hey
doing?
guys, how are you?
Good. How are things in? You're still in New York, right?
Yeah, well, Jersey, but
Jersey. Yeah.
yeah,
How's the weather? Actually, your weather is very similar to the weather where I am, so I probably already know the answer.
yeah, it's been a gloomy few days, but
Yeah.
not too
Same
bad.
here. Yeah, definitely the same here. Looking forward to some sun. So do we have a fairly light agenda today, it looks like? A few things on there, but not too much, which is exciting because we'll get a lot of time to talk about the incremental delivery stuff, which will be fun for sure. Hi, Corinne.
Hey there.
How's it
Hey.
going?
Pretty good.
Great. And hello, Stephen. And hello, Lee.
Hello.
Hello, friends.
How is everyone doing?
Keep on keeping on.
Lovely.
That's very good to hear.
Pulling up our agenda file.
Yeah, fairly light today, looks like.
That's all right. Sometimes a focused meeting is a good meeting.
Very much.
In which case we might not consume the whole time, which is totally cool.
Yeah, Defer has a way of chewing up all available time.
Fair enough.
So-
Yeah, fair enough. It is a important item.
Yeah.
We also had a light month last month, so I'm probably going to skip over our prior meetings review because it has actually been pretty steadily focused on incremental delivery for the last handful of meetings. So my sense is that everyone in the room's got as much of an update as they need. Otherwise, feel free to click through those manually. Otherwise, let's see, we've got quorum here. 5, 6, 7, 8, 9. 2, 3,
Yeah, most folks.
8. Almost.
Yeah,
Oh, I guess
Yakov
we-
is missing.
Yeah, Yakov is. Well, hopefully we see Yakov shortly. but I can get us kicked off. Hello, everybody. Welcome. It is May. Holy moly. Making our way through the year very quickly. What crowd could be a better one to spend a Thursday with talking about GraphQL? Of course, by everyone joining here, we all agreed to the spec agreement, participation guidelines, contribution guide, code of conduct. Feel free to click some links in the agenda if you ever want to brush up on what's in those. Let's do a quick round of names to faces. We can go in the order that is listed in the agenda file. And I'm at the top. So hello, everybody. My name is Lee.
Hi everyone, Benji here.
Hi all, Hugh here.
Hi, I'm Kawai.
Hi, I'm Corinne.
Hi, I'm Matt.
Hi, I'm Rob.
Hey, I'm Stephen.
Thanks, everybody. And hopefully we'll see Yakov shortly. Do a quick review of the agenda. I'm going to skip over reviewing secondary meetings and action items since we were focused. I have one other thing that I didn't explicitly add to the agenda. I probably should. I'll update the file after the fact. But just a quick update on the GraphQL Conf coming up later in the year. The CFP is open for a little bit longer. And this is a crew of people who has extremely interesting things we're talking about. So I really encourage everybody here to submit to that CFP. I will probably also be tapping a handful of folks to participate in the actual program committee. And so if that's something that is interesting to you, then reach out to me because I'm going to start to build a panel of folks, some of which will come from the foundation board and some of which I'd like to come from the technical team. That's all the update there. If anybody has any questions about it, I'd be happy to answer. Cool. Look forward to seeing everybody's CFPs. And Yvonne, welcome. We did intros already, but I'll let you say your name.
Hi, I'm Ivan.
Add yourself to the agenda file when you get a shot. Hey, and we've got Yakov. Yakov, we just did intros. Feel free to do yours.
Hi, I'm Yakov.
Thanks, friends. Ivan and Yakov, you may have just missed, I was mentioning a quick update on GraphQL Conf that is coming up, and that the CFP for talks is still open for a little bit longer, and just encouraging everybody here to propose a talk because everybody here has got really interesting stuff worth talking about. Okay, with that, and it's Rob. The floor is yours, and we can get into the incremental delivery.
All right, just give me 1 second to share my screen. Yeah, well, so we've been meeting every week, our incremental delivery working group. And I think that over the past few months, we've made a lot of progress. And so want to report back on that. Basically, like just to give like a reminder of like the big issues we're trying to solve. Basically, right now we have a version of it that's merged into main of GraphQL.js, and I have my spec PR that follows what's in there. And what's happening in that version is what we've been calling branching. And that means that whenever, as you're executing, you come across a deferred fragment, you just simply take the selection set under that fragment and begin executing it. That's like a pretty simple algorithm, but the downsides that it brings some downsides. And one of those is result amplification. So you have all these separate defers. There's a lot of fields here that overlap. Put that inside of a list or a list of lists, and you could end up with lots and lots of payloads. These fields are even executed each time that they're deferred as well. So that sent us down a path of let's try to deduplicate it. We discussed a bunch of things like merging defers at the same level, merging defers that have the same label or no label. Those didn't really shake out. And we also discussed a lot of deduplicating the results. So kind of having the same output, but taking the fields that are shared or in the initial payload and not sending them again, not executing it again. And here's like one example of a problem that we want to make sure we don't have, which is, let's say we have this most recent comment field. It's both in a defer and outside of a defer. We really want to make sure that it doesn't get executed twice. And if it does and it gets deduplicated, then you could have like a really weird result where the most recent comment changed in the time that the initial execution of the field happened and the deferred execution, and now try to merge those back together, and that's bad, that's wrong data. And even if we didn't do this deduplication and we return the whole objects here, then you end up with a situation where you can't really get like what we're calling a reconcilable final object, because you'll have fields at the same path and different results for them, and it's not clear how you could merge that into a reconcilable path. So this is like a preview of another document that we came up that we're calling the solution criteria. And that's a long list of things sorted by critical, major, minor that we've been evaluating against. I'm not going to go into this in this meeting, but the link is here if you want to take a look. So I'm going to jump into what our latest proposal is. Yeah, and this was a lot of work from a ton of work from Benji, Yakov, everyone that's been coming to these meetings every week. So this version, there's no branching, there's no duplicate delivery of any fields. The risk of response amplification is greatly reduced. We're not doing our like execution deduplication by caching, or we're not saying like execute it twice, but the first time like hold on to a cache of the results so then you don't call it a second time, because we think that could have some memory burden on servers. We previously discussed like methods where you look at a query and try to rewrite it to remove deduplicated fields. This is not doing that either. We do have consistent delivery of fragments, meaning that once you get the result of a deferred fragment, you know that you have all the fields that are there. We're not going down the path of merging by labels anymore. Labels are still in this proposal, but they are purely metadata. They don't affect execution at all. And there's some nuances about null bubbling that I'll get into in a little bit. So there's a bunch of examples here that I put together to try to explain all the different aspects of how this works. And so the first one here is a bunch of fields that are in your initial results and a bunch of fields in the defer. If you look carefully, the only difference between the two is I is in the initial and J is in the deferred, in addition to this type name field up here. And so you get your initial payload, and that has all the fields down to H and I. And we have a new pending array that tells you these are defers that are being worked on in the background of your server. They're what you can expect a result to come for. We give an ID to it, and the path is the path of where the defer is. This one's at the root of the query, so it's an empty array. Then inside of incremental, we have the actual data coming back. It's tagged with an ID, and so you can use the path from the matching pending ID for where the data is. If the data is nested lower than where the path referenced by the ID is. There's a subpath field that tells you to go lower. And then there's the data objects. And now in this example, if we say that J takes a really long time to resolve, you're not going to get the data for this type name field until basically all the fields for that deferred fragment are ready. So even if this one's is ready sooner, we're not going to eagerly deliver it now. Once J is ready, we know that the whole fragment can be resolved. We send those fields. We have a completed array, which mirrors the pending pretty much and just tells you the ID when you know that the fragment is done. And then our has next to let you know that there's no more additional payloads. This is a very similar example, but now there's another defer nested inside of the first defer. And this is demonstrating that when you get the results from the first defer, which is here, we're not going to resend the fields that overlap between the two because let's say like J and K are already sent here. They're not going to be sent again. So you have to use your previous results to know that the whole thing is resolved, but it's only sent once. And now that we have enough data to complete the second defer, you'll get the second completed with ID 1, which corresponds to that pending. So in this example, there's two defers with a that I've labeled red and blue. Red has the E and F field in here, and this field that we'll say is slower than the other ones. Inside blue, there's the same E and F field, and we have G and H and this other slow one. So the execution algorithm that we came up with, when it goes to resolve the fields here, once it gets to this level of where E, G, and the two potentially slow fields, they're both at the same level. It's going to like break them out into 3 sets of grouped field sets, because there's this one, slow field A is part of the red group, G and slow field B is part of the blue group, and then E and F is part of both groups. So there's like 3 sets that are independent. And that's how we determine like how the incremental objects are returned. So in this example, because slow field A returns first, you get the data with E and F and the data here. And then when slow field B is done, you get G and slow field B. These are in the same data object because they both belong to the same sets of defers. And yeah, and feel free to interrupt me at any time, like if there's questions or anything, because I'm doing a lot of talking. And so in the same example, when slow field B resolves sooner, it's the same 3 incremental objects are delivered. They're just come back in the order of where now the ones that are associated with the blue defer are returned together, and then the one that's left for the red defer comes later. Yeah, this one is a similar example where there's a list item and these fields are the same list item, and then but this one defer has ID and this one defer has value. So because list and item are members of both defers, they come back in their own incremental object. But then once we get inside of each object, we have to execute the ID and value separately so that whichever one returns can come back. And that leads to getting the data like this. So we say ID comes back first. Now you'll have these 3 fields for the 3 items in the list, and then the 3 values later.
Rob, would you mind scroll back to the previous example, if you will, the one with the potential slow field
Yeah.
A and potential slow field B? I guess I'm kind of already thinking about on the server side implementation. So basically you're doing a dedupe, right? If I'm understanding correctly. So the incremental 1 and incremental 2, like basically what happens if the cheaper field's already delivered with the first one, you want the second payload doesn't deliver it again.
Right.
I'm just thinking about on the server side, sometimes there might be race conditions that, okay, the second payload didn't know the first one already delivered, so they might send down the same data again. Do you think it would be okay for us to say like duplicate is okay as long as they're the same value? Sorry, if that makes sense.
I haven't really thought about it. Maybe. The way that we were modeling the execution was that there should be like 3 separate executions here. The one with EF, the one with potentially slow field A, and the one with G and potentially slow field B. And then separately, there's 2 like defer objects in your memory, and they hold on to references to those executions. So they're both going to have 2 references, but they should each be pointing to that same instance of the execution for E and F. And then so when this one's delivered, we can store that this has already been delivered. So now when the second one is completed, you should know that it was already delivered, so you don't have to send it again. So E should definitely only get executed once as part of this.
Got it. I see. So how do you decide on the how do you decide on like how do you plan out the 3 executions? Do you depend on like profiling data from the past to decide if they're slow or not?
No, it's decided entirely by which defers they're inside of.
Okay.
Yeah. Yeah, because this one, like it's they're split up by the unique set of which defers they belong to. There's like the unique set of being only in red, being only in blue, and being inside blue and red.
I see. So it's like based on analyzing the tree before execution, you
Right.
figure that. Okay.
Yeah, this one I think there's still some question that we're discussing. I think it makes sense that if there's no fields inside a defer like there is under A, then it should be dropped entirely. I think there might be some question about that, but that's a small detail that we could get into later. Yeah, and this one just shows that defers that are at the same path. So this billing and this previous are at the same level under me. And so it's like any fields that's inside of one defer, it's not going to block the returning of the other one. So defers at the same level, you can count on like them being executed independently, not being blocked by each other. So this shows some null bubbling, and I think this is like might be the most unexpected part of it, or maybe a little bit surprising. So there's 2 defers here. We're going to say that in this example, Quux is non-nullable and it returns null, and Baz resolves before Quux does. So if there weren't defers here, then this Quux would blow up and you would get null for bar. But because this defer finished first, we already have bar sent with the results inside of it. And now we don't want to, we can't go back in time and change this field that was already sent. I don't think we want to tell clients to start rendering something and then take it away. So what we're going to opt to do is basically cancel out the whole fragment. We're not going to return data for it. And we're going to say that in the completed, it's going to have the error that led to that conflict. So what's different here is if you didn't have the defers, this another field would get resolved, but this is kind of a casualty in this non-null bubbling that we don't have a way to resolve. Any questions on that, or should we move on to stream?
So I do have, I know I've brought this up in the working group, but I do have one, like, one of the values of GraphQL, at least in the response format, is that what you get in the response is essentially what you are interacting with on the product side. Like the JSON response from a product perspective, you write your keys, you get this tree back, and like it's very obvious how you stitch the data you got from the initial response into the product itself. And I'm not like, we're trying to solve here a potential performance problem in the n by n defers case, but at the cost of, from a client, like if I don't have a smart client, I just have a like JSON response reader, basically, the actual, like, I essentially need to make my responses mutable. My like JSON that I'm holding in memory now needs to be mutable, and I need to be writing directly into that response object and then re-rendering, which like that kind of breaks the React model, where you wouldn't expect your, like, in a reactive rendering model, you expect to basically, okay, I might append the amount of data I'm appending to my data, and that affects the re-render. But this feels like you all, like when I go to my re-render and I hit the pending payload, like the deferred fragment, the work to then make sure that I actually render all of the sub-deferred pieces feels like it feels non-obvious how I would build that unless I'm like keeping a mutable tree of pending, maybe completed responses that I'm like pushing into every time.
There is like, it's a gradual process of deduplication we went through. So the first stage was, I think it was Benja's proposal to deduplicate with initial response. And once we decided on deduplication with initial response, client need to maintain mutable or mergeable or some data structure of that type anyway. So a difference here is like previously client need to merge like keep initial tree, only one initial tree, but merge it multiple times, potentially with every incremental delivery he gets. He need to get initial response and merge it. Now data structure became a little bit more complex. Like I just wanted to point out that this think about mutable or mergeable responses is not a new thing of this particular proposal. It's like stuff appeared when we decided on deduplication with initial response.
Yeah,
I'd also like to comment, Matt, you mentioned that this is a performance issue, and that is originally what sparked this discussion. But actually, Quay, who's here with us, actually raised a really good issue, which is this lack of a reconcilable final object, this situation where if you query one thing in one area and then that same thing again with different fields, you might not be able to stitch them back together again, and you can't build a final object. Now, if your client is operating on a fragment basis, that may not be such of an issue. But for the clients who treat it as a final object, they want this final reconcilable object that they can deal with that's delivered over time. This is actually a major issue. Now, we've got two things here, right, that are potentially causing this. One is duplicate execution of the field, and the other is duplicate delivery of the field. And we can solve just the execution. So we could, like, for example, cache the execution of each field so that it never gets executed again. That would get rid of that problem, but still then just be delivering things multiple times. But it just seems that if we're solving the execution problem, solving the duplicate delivery problem at the same time, especially if we can do it using the field merging algorithm, which is what I'm proposing at the moment, does make a lot of sense, I think. I'd also like to add that the algorithm that I've proposed does effectively append only modifications. So it will never overwrite a key that already exists. It will only ever push to a list in the case of stream, or add new keys to an object. And it also does not do deep merging. So it's literally, here's an object, you've got your existing object, you add these new keys in, and that's it. There's no like deeper traversal than that. So I definitely sort of see where you're coming from, but we've tried to limit the effects while still gaining as many of the benefits as possible.
Yeah, I think that's fair. It's like yeah, I'm not trying to derail, but I am thinking through, like, do we actually have a client that like uses the responses as is and like tries to build a product of some form, even if that's like a feed of to-do list items or something like that? Like, because I know defer stream, like when we built it at Facebook, it was very like, we built it for specific product use cases. And yeah, I don't know. Yeah, I might be being a little curmudgeonly and possibly unnecessarily derailing. And that to me, though, is like the barrier for me being like, yes, this should be in the spec as is.
Stephen, do you want to comment?
Yeah. Yeah, I wanted to leave a little bit of space for that one, because this is a similar but slightly different question. And that is, so given this the current state, like this proposal, where we're deduplicating, would a client realistically be using the pending and completed fields here, or would we be just appending in as we get things, and then the only information the client really needs is has next? Like maybe the server is using some of this information internally as part of its bookkeeping, but basically, can we simplify the over the wire protocol?
The expectation that I have is that that the UI developer is pretty much writing a component that corresponds to the different defers, and the pending and completed is how the client is going to know to, okay, it's okay to render this component now because we have all of these fields versus it's okay to render this one. And especially when there's overlap between them. And we had also discussed that it being optional for a server to even execute a defer. And so the pending would be how you know that it wasn't just inline for performance reasons or something like that.
I see. Yeah, that makes sense.
And this makes sense, but I guess the question is like, I'm the client developer. How do I actually get that F field's value? Like, what is the actual algorithm that I have to work through when I'm in my product code, given the server responses that I have, to know whether or not I should be trying to get this F field, or whether it's like underneath, whether it's not coming back. That I think is a little bit more clear. That's the pending payloads bit. But then once we have once we say, yes, this pending payload has come back, how much of the response do I need how much of all of the deferred responses do I need to look through? Do I need to do a big O of N traversal on all of the responses to get to, oh, maybe F was actually returned in the red incremental, and like, how do I know when, like, where to look for it, basically?
I think the assumption was that once you get an incremental, once you get a payload returned, you have to apply all of the fields that are in the incremental to the prior response. And at that point, once you see a completed, you know that at the location where the path is for that given label, you have all the fields necessary to render.
Yeah,
component.
that's forcing a specific implementation of state onto, like, the client must implement state in a very specific way. Whereas like in today, like I can have a GraphQL client today that doesn't do defer stream, but does do potentially subscriptions, where the state model is like, basically, I just use the JSON as is, and I can traverse that JSON directly. I can traverse the response directly. I don't need to like store an intermediate object to keep track of what I've gotten previously. And that's not to say that we must not need that intermediate object, but it is to say like that is a downside. Like we would be transforming the language such that all clients must have this specific implementation of state.
Is the intermediate object necessary if you use a store backed client? Like, could you write all of the fields into the store? And
correct.
then...
That's essentially what you're forcing on the client. You either need a store that at least lives for the length of the like full response. And whether that store is just like a tree that you're updating, as you get the pending payloads, you're like adding to that tree, or whether it's, something else, but like you can't just take the wire response, read that from memory directly, whereas you can today. Like I have clients in the wild that just like their store is the JSON response.
In the context of defer, you mean specifically giving the deferred data for that comes back over the wire directly to the component or something like that?
Basically, like, it's fine. Like, obviously the deferred data needs to be split from the original response, but I want some deterministic algorithm on the client for knowing basically, okay, you said that this deferred payload is ready, it's completed. So now that it's completed, I'm going to do a render where the render object is basically this full list payload. And there should be some algorithm that I can use given the completed payload to basically, as I'm traversing, know where in that payload to be looking for the traversal bits. And I think that we could construct that algorithm like that. I think that all of the information is here. It's just a matter of like the format of that information as it exists right now requires a lot of like list traversals.
Just from my understanding, like would a simple version of that algorithm be something like you write this data you write the initial data into an object, you start with that, that's your base, the thing you're starting with. You merge every incremental. Once you get it completed, you find the pending, and then that path gives you the data that you need.
I'm saying without the merge operation, you can't. So assume that you have immutable data structures, because we do, and that you can't merge into the existing data structure that you got. How do you, like, what's the algorithm when it's an append only, like not even with, like, the tree is not append only. It's like what you've got basically is a list append only. Like what's the, like I can append entirely new trees to this list, but, or I can like have a map that I add items to, but I can't have a map of maps. I can have a map of trees. Like the current algorithm for like figuring out F would be for, or rather for figuring out potentially slow field B would be for each incremental payload. If the path is like walk through each incremental payload response with any ID to like using the original. So you definitely need to keep state of what the original ID1's path is. That's fine, whatever. But like from that original path, now traverse through each of them until you find potentially slow field B. So like you end up having to do 3 or 4 tree traversals in order to find potentially slow field B. Yeah, sorry, Yakov, I've been speaking over your hand.
That's okay. That's okay. I think I definitely think two things. One is like Rob and Benji had mentioned, we have an algorithm here that solves branching, I mean duplication on the execution, and that's critical. And I sort of see the simplicity of not doing deduplication in the response, meaning sending duplication response like you're saying. But it's sort of also the case that these are just different sort of serialization or wire formats, meaning you could have and it's much easier, I think, to go from the deduplicated data that Rob is showing back to the duplicated data, meaning you could have a little, like I put in the comments, you could have a little wrapper that sits between your naive client and the server that feeds the tree at the moment it gets it completed, sort of feeds the tree at that path that it sort of saved as a pointer to in memory, using that algorithm. And then it just produces that tree for the, at that path, that subtree at that path for the client when and now it's undeduplicated. So it would probably have additional information because it's the fully reconcilable object, but it wouldn't, it could create a new, object path there.
Yeah,
so I think it'd be, yeah.
So like that feels like this makes sense, but the like spec should not be concerned about wire format so much.
Hmm.
But instead, like the spec, at least in my mind, is more about the access pattern. Like when you are trying to get field C under B, like what must be available? At least from the client's perspective, it's more about like the access. And if you need, and like we have had completely different wire formats in the past. We used non-JSON wire formats that were spec compliant because we had the server on both the server and the client, we had that intermediary to like send it as that different wire format. And on the client, like basically convert it back into the access pattern that we wanted.
Yeah. So then we're in like a little bit of a bind because let's say we want to support both for naive clients and for sophisticated clients. It's sort of like, okay, well, we solved the execution thing, and now we're just talking about data formats that are interchangeable to some extent. But now we're just talking, like, I guess, about how to specify it best. And would that be a good summary or not so much?
It's essentially what the algorithm on the client is to be like the JSON. The thing about the JSON response format as it exists today in the spec, not counting defer stream, is that response format basically specifies the algorithm for accessing the data. Here, the response format is not the algorithm for accessing the data. And again, it's not that this is like, if we have this, then we probably also need to include in the spec what that algorithm for the data access actually is, not just what the algorithm is for like getting the data, like sending the data over the wire. And this basically forces that coupling of both. And that's fine. That's just like a additional coupling.
I think that this essentially comes out of the execution delivery split that I was discussing earlier. If we are in the spec making sure that things are only executed once, and we're not using things like now the server must have a cache, or whatever, then effectively at the moment, like GraphQL executes and delivers, if you will, a field in the same instance, right? It's all the same thing. You execute it, you return it, and that's what you send to the client. So if we are making it so that that the execution isn't duplicated, then we are, in the way that the spec works currently, we're also making it so it's not delivered twice. That's kind of an inherent thing about that pattern. So if we wanted to solve the execution problem, which is absolutely essential, but without removing these additional field delivery, we either need to split up execution and delivery and say, okay, execute it once, but then deliver in all of these multiple payloads, or we need to make it so that execution does caching and says, oh, if I've already executed it, grab it, but still return it as part of this thing. I think it makes the spec significantly more complicated. And though I agree that, the wire format is an interesting concept here, really, I think a lot of the, certainly the HTTP like JSON wrapping is basically take the stuff from GraphQL and return that in JSON format. It's not, compress it or decompress it or whatever. We don't like concern ourselves with that. So I'm a little bit concerned if we were to, for example, deliver everything as big things and then say at the network level, you should then like throw away those things and then re-add them again on the client side. That's going to make interoperability for the majority of GraphQL clients, which are JSON over HTTP, much more complicated.
Yeah, I think that's probably right. And like the way out feels like we need to like essentially, right, we need complexity on one end or the other of like, and it needs to be specified in the spec that this complexity does exist. This is an example, like when you're trying to access potentially slow field A, this is an algorithm that will work to get that field every time, and like to be guaranteed that you either like, this is how you know that it's not there yet, and this is how you know that like it is there, and this is how you actually get the value.
Whilst we're on the topic of problems, one other thing that I wanted to comment, that the current proposal, and in fact every proposal that we've had so far that talks about field duplication, deduplication, sorry, is the order of the fields within the maps is no longer guaranteed. So if you have an A, defer B, and then a C, where C is not deferred, then it's going to ultimately become A, C, and then the B, because that comes later. But things get more complicated when you have a mixture of defers and they come in different orders and things like that. So there is some complexity there that if we were not to deduplicate in the way that Matt's suggesting, then that problem would go away. I'm not sure if it even really is a problem, whether having unordered maps versus ordered maps is a significant concern at this point, when you're already using an incremental delivery mechanism where you're going to have these intermediate objects that effectively are going to grow over time, or they'll be replaced with something that's grown. Don't know, but it is worth at least acknowledging.
If the solution that you're getting at, Matt, but does that mean that it's fundamentally like not able to prevent this type of thing, like on a public GraphQL server getting extremely large amounts of data? Or
So I think that there likely is a way, and that way may actually be like essentially the way I would probably try to do this is make the response format for the incremental payloads like a nested tree response. Like we have all the data in the payload. Even in the incremental payload as it exists today, like we have that data available. It's just the algorithm for pulling it out. We're kind of deferring that into like, oh, that just needs to happen on the client by mutating this like this tree that we're building up. And I think you can actually represent the incremental payloads as essentially subtrees, just like we do in normal data, that you like provide a mechanism for how to like where those subtrees need to be stitched together. And if you have that and you're guaranteeing like, oh, this subtree, oh, here's where it has more deferred data. So when you actually get that deferred data, to like keep walking through, you can just walk through the tree, and you like end up with like the defers break the trees and like flatten them into a list of trees or whatever. But you should be able to know, oh, okay, I hit this point in the tree. That means I need to go look at that creates a pointer to the next tree that I can just keep traversing. That creates a pointer to the next one. Like I don't think the actual algorithm on the server for like deduplicating and all that is inherently incapable of this. Maybe I need to like attempt to write out exactly what would be required. But yeah, that's essentially like the way I see it, is like essentially the lists require client side building up that tree. If we're going to have to build up that tree and it's the exact same amount of data to send over the wire anyways, maybe we can have the format be the tree that we would expect clients to be building up.
Is that possible when you have overlap between different defers?
I think so. It might require us to go back to the idea of like having the defer change the format, like having some tag in the data. But if we're like, I think that is a trade-off, and there's a reason why we didn't want that trade-off, but that's a trade-off that like maybe there is enough value in not ending up with these like flattened list of things you have to merge.
I actually thought about this for a long time, and it's like relates to your fragment alias proposal, and you show like another format. Realistically speaking, it should be JSON compatible. And with JSON compatible, I want to share this problem. If somebody can crack it, because I'm like trying to solve this puzzle for a long time. Puzzle piece is like that. If we assume, and like in whole this discussion end up like we cannot assume anything about a client, basically. So if we cannot assume anything about the client, we cannot assume client is able to parse query or understand IST. If client cannot understand IST, it cannot distinguish between scalars and structures, like types of GraphQL types. So if we decide on any special syntax inside JSON, person who tries to attack or inject, people use random JSON on some systems, and inside random JSON you can use whatever JSON is supported. So whatever $sign, array, special names, everything can be put into JSON thing. So a simple client who cannot distinguish between custom scalars and fields mentioned in a query cannot understand is it a reference or is it somebody maliciously injected similar references at the scalar. If somebody can figure it out, it would be a breakthrough. I'm it's some way to escape value or something. I cannot without breaking compatibility, and JSON scalar is widely used, or JSON types things widely used in community. So, and in a lot of cases, these things actually contain data supplied by third party. So we cannot assume it's even sanitized. So just want to mention here, I also think it's kind of holy grail solution to inject something inside. I'm just thinking about it for months already, and I didn't figure out how to do it, not in a new format, but inside JSON.
You could solve it in the same way that MIME boundaries work, i.e. specify along with the initial payload a magic string that will never appear in the document and then use that as the identifier. Now, the challenge with that when it's a long-lived string is you can't guarantee that someone's not going to then take that and feed it back in, which could be an issue. But for incremental delivery, I think it's meant to be effectively it's effectively a point-in-time execution that is spread out. So you're not meant to be like reflecting mutations that then happen based on the results of what you're querying. So hopefully it wouldn't be such a concern. Or it would at least be deliberately malicious, in which case, you know, the client is party to this. But yeah, that's one option.
Client should do an escaping. We should have like an escaping mechanism. In the case with magic string is oh yeah, we're going too deep into that solution. We can probably discuss it on Monday. But yeah.
Something else we could do, I haven't completely thought this through, is but right now, because each item, each tree in the incremental list could appear more than once, we have a choice between which ID to send, and so we've chosen to send the one with I guess the shortest subpath or no subpath. But in theory, we could change that to you know, sort of labeling each tree in the incremental list with all of the IDs that it's included in. And if that extra information is given to the client, they could choose if they want to, when they see the completed payload, I mean, they sort of now have more choices. And because we currently are only giving them some of the IDs, they have no way of associating the completed object with those incremental payloads without going back to the final reconcilable object. But if they want to build some sort of map instead of a tree, if we give them that extra information, I mean, in theory, they should have it, I guess, or they could derive it on their own, I think. But we could give them that extra information, and then it's sort of like built into the response, like a little bit of a tree shape. I haven't completely thought that through, but seems like it might work.
So this would basically mean multi-pointer walks, right? Because you could say, oh, I'm trying to get a field. I know this field is under ID 1. So what are all of the ID 1 incrementals? And now, like, walk those paths until either like the path that I'm walking is not there. Like from both, so I'm going both from data and all of these incrementals, walk those paths, basically, like you can, yeah, walk them. It's roughly equivalent to a merge, but you don't actually have to do the merge. You can just walk them all at the same time.
Right. It's sort of the equivalent, I guess, of what the server would have to do. If it chose, I mean, really, it should just pick a, yeah, it's sort. I think it would sort of be equivalent of what the server would have to do with deduplication of execution, but choosing not to deduplicate delivery. I guess the server would have to do that, actually. And so we're telling, I don't think they're, yeah. So we're telling the client that they could do that. I mean, I think the better option for the client, it would be to just build that final reconcilable object as kind of a wrapper, like the first solution. But basically, I think I sort of agree that this would be definitely a model, like you said, it would be a change that would force a certain vision of state on the client. And in my mind, it's just kind of worth that. So I'm not sure if, you know, if that's really an answer.
Might be true. That might be true.
Yeah, so that was helpful feedback. I guess
yeah. Where does that leave us?
yeah.
Yeah. Do we want to talk more in depth about this in Monday's meeting? I don't know if you can make Monday's meeting, Matt.
We've not gotten to stream yet.
Oh yeah.
Yeah, there's only 2 examples, so I guess we can do that real quick. Yeah, so a defer and a stream. I don't think it should be too surprising based on what we already went over for defer, but so there's appending for the deferred data. there is a pending for the stream. There's only one pending for the whole stream, not one for each item. The path points to where the stream is in the tree. The incremental data is not going to have a subpath, but because the stream is always just pointing to where the list is. It's items inside of an array, so we can return more than one at once. That's what we have even on the main branch of GraphQL.js now. You can get the completed not with any items because the stream can close asynchronously. And yeah, so here's like a payload where there's no incremental at all because we're just saying that the stream finished. And then here's like the data that was from that original defer that closes out the whole response. In the case where either you have the stream and the list item, in the case where you have the list field and the list item is non-nullable, and you get a null or an error that should have bubbled up, which without stream would have nulled out the whole list field, then you're going to get this case where we return the completed with errors for the stream. And so you should take that as indication. There's no way to go back and undeliver the stream items that were already sent, but this is letting you know that this error would have bubbled up. And this would also be the case if your like underlying async iterable or whatever it is errors out after delivering some items. Yeah, that's all that I have for stream. We did in the previous version have a path on each stream item saying like what the index of the first thing in the list was. And I think there were a few reasons for that. One of the main ones was that because of the way we were branching defers, it was possible to have multiple streams running simultaneously on the same field, which I think is not desirable. So I dropped the ID here, and I'm just saying that you're getting the list items in order. It's append to the list. Yeah, that's it for stream. So we're saying Monday, if you can make a map, that would be great. We can go into this. Do you think that there's a path here where most of this, like the underlying execution is the same, but we just need to tweak the response shape? Or
yeah, I think that the underlying like server algorithm at this point feels strong. Like, I don't think that there's a fatal flaw in like how we are doing the deduplication. I think the potential fatal flaws, like we've been considering this very much from the server perspective, like what is required to get this to work on the server, what's required to make sure that we aren't like wasting work on the server, that we're not allowing injections. And I think that that is the strongest piece of the proposal so far. And I think it's very strong. But like, I don't think we've tried building a few kinds of like toy clients or whatever with the model. Whereas we've built basically toy servers with the model. And so that's, yeah.
yeah, it feels like we have all the data we need on the server. We need to present it the right way.
Yep, exactly. Yeah, and that's why it's like, it's all format questions in my mind. It's not really, and it's like, what's the shape? Not what's the like, what are we even trying to do?
Okay, yeah, sounds good. I know that Yakov has, I think, most of this implemented in GraphQL.js in a PR. I think that we should start looking at getting at least some of it merged in and released under an alpha. because I think that it's good to, it would be good to have that execution algorithm in place, even if we still we're still changing the results output. So maybe me and Ivan and Yakov, we can work on moving that forward. All right. Anything else that we want to go over about this now?
I think we're good. Is that our last topic? Oh yeah.
Yeah, I think so.
Anything else we want to talk about? We can on the Apollo side, we can definitely volunteer some time to help vet things once they're in the alpha on the client side. Now, our clients are different than other clients, so I don't know how much that's really going to vet things, but we can help smoke test some of the ideas anyways.
Awesome. Matt, just to ensure that I fully understand what you would like to see, are you effectively saying, given you have this like response stream that you've built up over time, and you have, let's say, a path to a field, you want a basic algorithm that will give you the value or values that could be used to build that without using mutation?
Yeah, basically.
Cool.
Because that would be, if we have that algorithm, that is the algorithm for merging that basically, right, that's the thing that we're saying the client must behave in this way.
Cool. All right, fantastic. Well, thank you everyone for this very interesting discussion. I think we are definitely getting closer to stream and defer becoming something that we can merge into the spec, but still lots to be thought about, lots of edge cases and things to be explored. So let's keep up the good work, and I'll see many of you on Monday.
Yeah, this is awesome. Thanks very much, everybody. Take care.
Bye, everyone.